This will be a talk about the work done by something else. And it probably makes sense to introduce myself. And I think the key point here is that I'm coming from the academic side. I teach mathematics and teach programming. I teach Clojure, and also my research is actually very much connected to functional programming. I'm doing semigroup theory, and I'm also interested in the mathematics and computer science education. So what is the goal here today? Okay, so what is the question is that what is declarative programming? Okay, you might have heard this question, and we are going to answer it in a philosophical way. Okay, so you have been warned. So let's start with as we do in philosophy, we start with the obvious. It's like, yeah, everyone knows what is declarative programming, especially here in the functional programming conference. We have the good old style. Here is old style Java, just doing something very simple, finding even numbers and collecting them. And you have your for loop, and you set up all the machinery. In contrast, you have a functional program where you don't just describe how in giving comments, but you tell exactly what to do without specifying how to do it. So it's more of like stating the result. So that's probably, this is something that everyone knows or everyone thought about. Before we go further, let me just mention that okay, this is not only in programming and in teamwork and in human psychology. There is this idea of communicating the intent. So this is a very good source of that. And that's describing the intent is declaring the goals. And you can contrast that with micromanaging. So micromanaging is a word, and it's like you can ask yourself when you do programming, am I actually micromanaging my computer, or I'm letting the computer do what I actually want? And if you just read the quote, it's the first sentence says that the art of describing intent is to give as little information as you can. Okay, and that should remind us, like, how we design interfaces and libraries. Okay, as I said, we do this philosophically. So now here we have 2 plus 3. Okay, that's a very simple thing. Is this imperative or declarative? Okay, and the thing is that you can argue both ways. You might say, oh, this is very imperative because I'm actually telling that, adding these two numbers together, and you can imagine it's part of a lot bigger statistical calculation. This is very, very imperative. But you might also say that, wow, this is very declarative because I'm not specifying how to do the addition, and I'm giving no information about the binary representation, the processor registers, and things like that. So the conclusion here is that being declarative is relative. Okay, that's not an essence. And well, I guess everyone knows this optical illusion. It's like, yeah, this is like being a particular shade of gray is actually also relative, because believe it or not, A and B, those squares, they have exactly the same shade of gray. And when I put this image in, I also did not believe it. So I actually went into GIMP and cut pieces out and compared and used color picker. But yes, that's how it is. Okay, so I mean, I already concluded that it's not much point to talk about this one. So I suggest something else instead. And here is this schema. So let's try to use this. I call it the who does the work schema. Okay, so we need to think about when we work with the computer. So what is the manual work, or what is the, well, to be more precise, the cognitive work done by us? And what is the work? What is the part of the work that is done by something else, or namely the computer? So let's go through some standard examples in Clojure. So now, of course, I don't assume that everyone knows Clojure, but it's not a big deal because it's it's a very simple language, so to speak. It is a Lisp. So whenever we write f of x on y, we write it in a list notation, and the first thing is the function. And we are very consistent with this one. Instead of 2 plus 3, we even write plus 2, 3. So that's Lisp for you. And people would say that, Lisp is just too many parentheses. We don't have this problem in Clojure because of the additional data literals. So we have the list, which is the traditional list, and we have the vector with square brackets. That's just sort of random access sequence. And we have the hash map with the curly braces, which is, it's good enough to play object orientation if that's what you want to do. So here is a book object. And the symbol starting with the colon, those are the keywords. So another way, I'm doing, Clojure in a nutshell, Clojure on a slide. So I have to dramatize it a bit. But you might say that, Clojure, since Clojure programs are expressed in these data structures, in other words, you can think of the language as just, it's a fancy JSON. Yeah, it's a bit sort of better data literals. Everything is immutable by default. So yeah, that's a property that people like here. It's a hosted language. It's hosted on JVM. The core language is very small, and much happens in the libraries. And maybe the thing that I like most is the REPL-based development. And okay, here's how it looks like. So it's like I have the source code on one side, and I edit it, and I can just evaluate little pieces of it. And if I change the function, I can just dynamically put into the running process, which is on the other plane. And I can sort of sculpt my data and try to figure out how to solve this problem. So this type of workflow, I guess it should be possible in other languages as well. But this type of workflow sort of totally got rid of the traditional style of debugging, where you start and you go step by step, because it's like by the time I get it working in the repo, then I just copy the result back, and that's my finished source code. So yeah, that's my personal style. As I said, I'm working, I'm doing research, so I can choose my language the way I like. But in case you are judging programming languages by the creator's video background, well, then Clojure is not a bad choice. Joking aside, I do recommend reading this paper or watching this video. Clojure is now old; it's 15 years, yeah. So it has a history, and it's an interesting history to learn about. Okay, but getting back to my goals. So it's like I'm going to do these examples in Clojure, and we try to use this schema, what part is manual and what part is automated. And let's just do this functional collection processing. It's the map, filter, and reduce as well, or fold, if you know it by that name. So what is the in filter, what is the manual thing you have to do? Well, it's like if you don't have the function, you have to write a function which deals with a single element, okay? And whatever you want to do. So with a single element of the collection. And what is automated? Well, the mechanism of processing the collection, the setting up the loop and knowing when it's finished and going through every one of them. So yes, I teach Clojure to complete beginners as well, meaning that they haven't even done any programming in any other programming languages. And there is a difference. They get this very, very quickly. But those people coming from the older style, they struggle with this because there seems to be a natural resistance against giving up control. What more, and this is something to be studied by cognitive neuroscience maybe, is that even the innocent people who never did a for loop before, even they show signs of trying to actually do. It's like, oh, I have to go through the collection, so I have to do it myself. And of course, talking about declarative here, if you don't deal with how it's done, well, then it's easy to switch. And it's like it was a lifetime achievement unlocked. Finally, I had a problem which had the right size, and I could use PMap, which is just map, but it's done parallel. And I didn't have to do anything to make it parallel. Okay, and of course we have a very general idea as well, and that's pattern matching. You specify a pattern, and that's the manual part, and the automated part is that we find the corresponding values for those tokens. And here's the 15-year-old Fizzbuzz. And here is the sort of the more traditional way of doing it. You just have conditionals. You have to think about the order, of course, but it's sort of fairly straightforward. You can do this with pattern matching as well. So here it is slightly different. You actually create a pair. So those are the remainders. And then you match this. This is the piece you are matching against the pattern. And that's, you know, it's probably, it boils down to exactly the same sort of control flow, but you don't have to do the conditionals. So then here's a similar one. Again, it's keep it very simple, and it's a standard example. You just want to calculate the slope of a line, and you represent it with two pairs, the 2 points. And it's like, here's one way to do it. You calculate the slope, and it's like, we really don't like this code, right? Because you sort of have the actual calculation, the algebraic expression, the business logic, mixed up with extracting the data, because it's coming as a single argument. So we can do this better, of course. We can do this manually. And so you can use let bindings. So you actually give names, you get out of the input structure. And now this is nice because it's the algebraic expression is separated. So yeah, we are happy with this one, but we don't like to do this work. So again, it's like that work of giving those names and figuring out where they are, that's, we don't really like. That's why we have destructuring. And we just give the shape and of the input. And what is automated, what is done for us, it's extracting the data and do the local bindings. Sort of next step, you might see that you might often have this issue that you have like a map, so a piece of data, and you just need to transform it. So let's get some pieces out of it and then rearrange it. So here we have the 3 key value pairs, the x, y, and z, and we want to separate the x, and the others, the non-x's, that we can just put together. So in plain closure, well, you know, again, we can just have a new hash map here, and simply we can get the information out. But if you use this library, which I just found when researched this talk, the Meander library, you can do this with pattern matching as well. So here you are actually specifying these logical variables with the question mark, and that's like the first is the shape of the data, and the second one, the second hash map, is the shape of the output. And it's like, okay, this is a very simple example, and of course with that library you can do a lot more because you might want to process these and do something. But you see the idea, it's like you don't have to do this manually. Again, there is an automated part for you. And this is getting to the logic programming. It's because it's almost like that one. It's like, well, you specified constraints on variables, and then you have the engine. You just pump it through the engine, and you find models satisfying those constraints. And let's do an example. Textbook example, do permutations of a set, and you can do, again, the good old traditional recursive style of doing the recursive way, fix X and permute the rest. And you can do it in a different way, and that is if you use the logic library. Okay, it's has a bit of an infrastructure to set up, but basically the part which is interesting is are the last two lines. And basically you say that, well, this P, and this will be the structure we are interested in, we want to have all permutations. All elements are distinct, and they are all coming from the same finite domain. Okay, so we do not see what is happening, just define how the solution look like. And we only specify the input to an engine. That's, again, that is the automated part. And here's it's one of my favorite libraries. So it's almost like the goal is that, oh, let's try to figure out a talk where I can mention this library. And that's the InstaParse library, where you can do your own parsers very easily. You just give the grammar, and then with that parser, you can have the parse tree. It's done, and of course, then you do whatever you want to do with that. And it's like I can see that people like it. I loved it too, and I actually used it in my research project where I have to process Go game records, and then I have to do the smart game format files. And it's like, I would need to write a parser. And it's like, oh, but I don't want this. But it's all automated. It took a bit of time to actually get the grammar right, but after that, it's all done for me. And now I hear you. It's asking us like, oh, wait a minute. Does using a library qualify as declarative programming? And I would say yes, because if you use a library, what you have is a collection of functions. You can think of it as an engine, and you just specify the input. You just give the parameters, and you don't care about it. So it's like, yeah, calling a function from another library, that can be understood as declarative programming. And so, yeah, this might be the moment when you regret following this talk, because now we can conclude that, oh, if that's so, then actually all programming is declarative. Because what is digital computation? What is programming computers? Well, you have the manual part, which we have to do. We write the code, and then there is the automated part. We have a runtime that executes our program. So, well, yeah, here's philosophy for you. It's it's like we don't even know. We knew before what is imperative, what is declarative, and now it's all came together. But okay, the conclusion here is that being declarative is relative, it's context sensitive. It's not in a sense. So please do not expect a strict classification of languages and language features. For example, it's like, oh, map is declarative. Well, compared to the logic programming, it is actually very imperative. But hopefully, this tour of language features was a bit enjoyable. And my point is that the work done by something else, schema, is actually useful. I'm telling it to students when they do something. Sometimes, before they figure out that functions can be nested, they copy paste the result into the other expression. And it's like, who is doing the work? You are doing the work. The computer should be doing the work. So yeah, think about the schema and always ask which part of the work am I willing to do. And whenever you learn a new language feature, a new library, yeah, think about this question. Thank you very much.
Now, can you hear me?
Yeah, I can hear you. Yeah.
Thanks for the talk. 1 second, we will have to do mic check. 1 second.
Okay, I see the question, but I'm not sure whether I should start answering it.
Okay, we will have some echo in the room, but let's proceed with the Q&A. Attila, can you, do you see the questions?
Yeah.
Yeah, so go ahead and please answer.
Okay, so yeah, what is the future of programming? I mean, if you go through the history, then you see that okay, it does make sense to talk about us becoming more and more declarative. And if you you heard about machine learning, some people say that well, that's the it's the next version of programming. You don't do any programming, you just give the data, which is super declarative. On the other hand, if because being declarative is forgetting the details, it's abstraction, right? On the other hand, if you ask Donald Knuth, he would say that well, as true geeks, they always stay on all levels of abstraction at any point. You don't forget about it. You know everything. So it's like, well, that could be still part of the programming, but certainly there is a trend. I argued that, well, there is not much difference between declarative and imperative as essences, as ultimate qualities. But yeah, sure, you can, as you climb the ladder of abstraction, you can talk about it meaningfully. Oh yeah, it's what is the best way of learning, understanding abstract ideas? It's just you need time to get used to them, and that's it's like I've been doing sort of very abstract mathematics as well, and I can clearly see the moment when I just lose it and I don't understand it anymore. Then it's go back and spend some time with the abstract idea. Then if you spend time with abstract ideas, they become concrete, and you can go for more abstract. So yeah, spend time with them. Yeah, so if everything is declarative, then nothing is declarative. Well, yeah, you nailed it. I mean, that's what happens if you sort of loosen up your thinking and you do a sort of philosophical one. It's a philosophical conversations, but then it's like the reason why you want to loosen your ideas because you want them to sort of freely combine. Then you go back and then you realize that okay, next time you have an argument about that, oh, this language is more declarative, then it's like it's like what to talk about, what is automated and what you need to do manually, and how do you value these parts of the work. So yeah, I mean, that's right. It's typical philosophical sentence. Okay. I think what is common, it's like I know people would argue that there's nothing to do. They are both trying to understand the word. Okay, it's like they try to come up with a model of the word. Of course, programming is a bit more practical because you want to solve a problem, but still, that's the idea. You want to build a model of the word. And yeah, of course, the philosophy is not concerned about any constraints about what sort of model you can build, but still, it's about model building, understanding the world through model building. Okay, yeah. Why choose enclosure? I would need to think about it. I mean, the closest answer is that, well, I seem to like it, and since I work in either alone or at like two man team, we can decide our tools, and that's like it's actually for saving work as well. It's very good libraries, very good library ecosystem, and sort of I can move fast. But yeah, the true answer is that I seem to like it for some reasons. Of course, this is not a professional answer, but if you go and look, and people will tell you, it's like, why do they choose it for business? So I mean, I was like, this is a different type of answer.
Perfect. Thank you. I think that
Thank you very much.
was all. So thank you for the
Okay.
great presentation. Let's give a warm round of applause to Attila.
Thank you very much.